Are you ready for me to start?
Well, we're at 4 minutes after 8:30, so yes, Rocky, I think the floor is yours, and I can stop sharing, and you can share your screen and talk about any of the things that you wanted to cover to begin with.
Okay. Okay. So when the moon first comes out and it's a new moon, if you look at it with binoculars, one of the first features you'll see is let me get my annotate back. Is this Chrysium right here? That's Mare Chrysium, and it's one of the newest Maria. And if you look at it through your telescope, you'll see that it's got fewer meteorite, fewer craters than the older Maria, and it's also got steeper walls on the sides. So that's why I wanted to start there, because that's one of the first things you see. And the second thing is see this bright spot. One thing that when you look at the moon enough, you get to seeing not just the Maria, but you see the bright spots. And this right here is one of the newer craters on the moon. It's Proclus, and it was done in the Copernican era, which is about the last billion years or so. Which sounds like a lot, but it's kind of the moon's 4.5 billion years old, so it's the most recent impacts on the moon. So Proclus has, and you can see the rays coming out from it right here and right here, and this whole area lights up pretty good through a telescope. It's a small crater, about 28 kilometers in diameter, so it's not a very big crater, but it's one of the brighter spots on the moon. Okay, now move, let me see, right down in this area here, that way. How's that? Can you see that, Chris?
Yep.
Okay, so that's good right there.
Hey,
back up
Chris,
just a little.
can you brighten it one step?
Yep, I can. How about two?
I think one was about more like it.
Okay, there we go.
Okay, this C right here, Mare, is a Mare serenitatis, and it's another young Mare, so it hasn't got a lot of craters in it, and it's got pretty good definition around the walls. But main thing I wanted to show you here is Apollo 17, which is right in this area. If you'll come down just a little bit, move up just a little bit there. There you go. So Apollo 17 was right in this area, and it was the most difficult Apollo mission. I think this is Lithrow, the crater Lithrow, and this is the Taurus Mountains. So it was in the Taurus Lithrow Mountains, and it was the most difficult landing site. And let me see if I can figure out how to share a screen with you. Okay, can you see that?
Can.
Okay, these are the geological eras that we'll talk about for the various formations on the moon. But the moon was formed about 4.5 billion years ago. And the first era is the 4.55 to 3.92, and so you've got a lot of really old craters and stuff like that, and we'll see some of them where the walls are broken down, and there's the center peaks are broken down. They've got impacts in the craters, and then the Nectarian era, which and the Imbrium era, where the flooding of the craters started, the seas and craters started the volcanic action, and then the Eratosthenian era. I have a hard time with that one. Eratosthenian era, 3.15 to 1.1 billion years ago, and that's relatively new for the moon. And then the newest is the Copernican era. So we'll look at craters with those in those different epochs. So I wanted you to see what that was. And here is Apollo 17 that we're looking at right now, with Lithrow and the Taurus Mountains around it. And here is where the the Apollo 17 landing site was. And you can see those are 6,000 foot peaks on both sides of it. So they learned a lot by the time they got to this, if they could land there. I'll show you Apollo 11 in a minute, and they chose Apollo 11 landing site because it was flat. So they came a long way. Let's see. Okay, this is a sketch I made of it last year, of the area, and here's another picture of it. I'm going to go ahead and show you Apollo 11, so we won't have to share again, but we'll get to that in just that's next on our list, and we'll see these, and I'm sure Chris will be able to show us these. We'll see these two craters. They kind of lead you to the Apollo 11 site in Mare Tranquillitatis, and a challenge is to see these three craters that were named after the astronauts, Aldrin, Collins, and Armstrong. And the best time to look at features on the moon is when they're real close to the terminator, and so it's pretty difficult to see these unless that area is near the terminator, because they're pretty small craters. But you can see where Apollo 11 was, and it's really pretty easy to find using these. See this little configuration of craters? I kind of crater hop like we star hop in astronomy. So, okay, Chris, I'll stop share, okay?
All right. So you tell me where you'd like to go.
Okay, Apollo 11 site, Mare Tranquillitatis. I think let me get my annotations back on.
All right.
This direction. Actually, straight down.
Okay.
Okay, right there you are.
Okay.
Okay, see here's let me clear that one arrow. Here's the two craters I showed you, Ritter and Sabine, and this little crater configuration, and they're pointing right to Apollo 11, which is right in this area right here. And you can see, you can't see those little bitty craters that were in the picture I showed you, but through an 8-inch or a 6-inch maybe telescope or a good refractor, you can see them when they're near the terminator.
Rocky, point out the craters that you're talking about. I see them, but some people might not.
Okay, I didn't. Okay, this is Ritter and Sabine, and Apollo 11. You just kind of follow them and kind of make an arc around like this. And Apollo 11 is right in this area right here. It's where it landed, in Mare Tranquillitatis. And Tranquillitatis is an older mare, and you can look at the edges of the mare, see how they're beaten down pretty much, and there's not edges in there like a crater normally would have raised walls on the sides. Apollo 11 was the site was chosen because of the relative flatness of the site and not very many boulders and stuff like that. And it's a good thing they chose that, because they actually overshot their landing point by about 4 miles. So and you saw in the previous shot we had how difficult it was. Even the second lunar landing was pretty much pinpoint, and from then on they were able to land where they wanted to. But the first time it wasn't. Okay, any questions about Tranquillitatis or Apollo 11? Okay, Chris, let's move up that way.
All right. Looks like we need to make things a little bit less bright.
Yeah, they seem to get brighter up at that end of the moon.
All right. Does that look about right for everybody?
Okay, over to the right. I mean, this way. Yeah, there you go. Keep going. Okay. This is what I chose to look at here was, this is good. This is Mare Fecunditatis, and it's an older mare. older sea, so it's got a lot of craters and stuff in it. And a couple of interesting things in Fecunditatis is Langrenus right here, which is, let me circle it, which is another new crater. And you can see it's white. Newer craters are white because they haven't had the action of many meteorites and stuff like that, and solar rays and stuff. Over 1 million or 2 million years, it causes that bright spot to darken. A billion or a couple of billion years, it causes that bright spot to darken. One real interesting pair of craters here there's different, you can see them pretty good right here, is that's Messier A, and y'all have heard of Messier before. Messier A and Messier B. And you can see the rays coming out from them, and it kind of looks like either a couple of them hit at the same time, or one of them bounced and made two craters. Maybe we don't. I'm not sure of the complete history of that, but that's very interesting to look at through a telescope and do a little study on. Okay, now we want to go to this one right here, Chris. That area right there.
All right.
Okay, and this is Mare Nectaris, which is what the Nectarian age is named for. So when this was formed about 4.1 billion years ago or something like that, that's the start of a new period. So so that's a pretty important sea. We've looked at just about all the seas on this side of the moon now. If you move over just a little farther to this way, see if I can find it. That's good, I think. Yeah, here you go. This is the down just a little bit this way. No, I'm sorry. Go this way. I told you the wrong way.
It's all right.
See this? This is where Apollo 16 was this area, and see this bright spot. That's the way I was able to find it, because it's kind of hard to find, because it's kind of like trying to find the comet in Camelopardalis. There's not any features there that direct you to it, but this white spot right here, if it's not when it's close to the terminator, you won't see any of these white spots. But as it gets away from the terminator and the sun gets higher in the sky for the moon, then you start seeing the lighter areas of the moon. So it was the only Apollo mission to the lunar highlands, and they made some real important discoveries with their rocks there that they collected in Apollo 16. It was between Lindsay, which is this crater right here, and the Descartes Foundation, which is right down in here. But you can find it. I find it. It's easy to find with the bright spot, but it's a little harder to crater hop in there. Okay, now let's get down to a really interesting part of the moon. Go back down to where you started out, Chris, down near the Alpine Valley.
So you might, Rocky, for those on this virtual lunar session that don't realize, I'm looking at this in two ways. But right now I'm seeing a lot of scintillation, a lot of seeing as it comes down real time. I don't know if we're seeing that in the presentation, but there's me recentering the scope, and then there's just the kind of image just kind of fishing around like a swimming pool. You might
a little
to
bit.
folks.
It's actually pretty good, especially on this end of the moon.
All right. Well, you might explain to folks kind of what's going on there with looking through the atmosphere and how things are.
Oh yeah, because you get that through your telescope too, don't you?
Right.
Yeah, the atmosphere shakes and causes your seeing to vibrate, and if you're looking through a telescope, you'll see it through a telescope too. And so your best nights, when you have the best seeing, is when the air is real still, and not a lot of air currents moving, and then you can get some really nice views. Or if you're up on a high mountain or something like that, that helps too. But down here, we'll start with these. This is a nice pair of craters, Aristotle and Eudoxus. and they're both young craters, the Aristotelian period and the Copernican period for those two. And then one of the most interesting features on the moon is this valley right here. I'm sorry, I keep forgetting. I use my pointer and forget to draw. But the valley is the Alpine Valley, Alpes Valley, and it's in the Alpes Mountains. Actually, I told you wrong. It's in these are the Alpine Mountains. So they named mountain ranges on the moon after the mountain ranges on the Earth, and you'll see a few of them.
Brighten it a notch, Chris.
Pardon?
Brighten it a
Take
notch.
It up. Brighten it. All right.
There you go.
But the Alpine Valley, you'd think it might be where a crater, where a asteroid or something came down and just swooped right across the surface of the moon. But they think what it is it was a what's the word I'm trying for? A tectonic feature. It was it's something that was caused when Mare Imbrium, which is this area, this mare over here, and it's one of the biggest ones on the moon, was formed, and it caused some fissuring in the Earth and a crack in the moon, and a crack right there. And actually, it's a lava-filled floor. It's got lava in the floor. But that's a real neat feature on the moon. This is neat. This is Mount Piton, which is a very tall mountain on the moon. It's not a real tall one, but it's out there where it looks tall. It's about 6,000 feet tall.
Rocky, you see that medium-sized crater just below and to the right there that's filled in? It's an old crater that's filled in with a lava flow.
Right here?
And then it's got a couple of craters inside See how that's awash with obviously a crater that was made before the Maria.
Or during the Maria. It was probably, the crater was made before the Maria, and then when the Maria flooded, it flooded that crater too.
Right.
And you see a lot of those on the moon. I'll figure out what it is. I think that's Cassini. Yeah, that's crater Cassini. Okay, Chris, and this was the Caucasus Mountains and the Alpine Mountains, I think. Come on up this direction now. Okay, that's good. Okay, this is a very interesting area of the moon. This is Archimedes, the crater Archimedes, and Autoclus and Restilius. But what's interesting about them is this area right here is where Apollo 15 landed. And it landed, I think, back in this area right in here. And there's a very pretty, very neat, and you have to have good seeing. And I've drawn it before. Hadley Rill is where Apollo 15 landed. And of course, Apollo 15 was the first one that had the lunar rover. So they spent a lot more time out on the moon and went a lot longer distance. But before that time, they really didn't understand what those rills were. And I think I'm going to ask you to let me share a screen. Let me show you a couple more pictures of that area.
All right, I'm going to stop. All right, so now it's all yours.
There was the Apollo 16 landing site that we looked at a minute ago with the crater Lindsay and the Discardi region, and here's that white spot we saw. Okay, and see, this is Apollo 15 that we're looking at, and here it is in relationship to Archimedes, these three craters, and it's back in these hills right here, and you can see the rill. And you can actually see that in this crater, and they actually got close to this crater, I think, with their rover. I used to know the name of that, but this is a really interesting region to look at through a telescope.
And so what's a rill?
That's this right here.
But what is it?
That is like a lava flow where a river of lava went, they think, at one time. You know, the lava hardened around it, but there was still a stream of molten lava that flowed down through there. But this is one of my favorite regions of the moon. This is let me go back to your share. Let me see if I've got any other slides here. That's my last one. So I'm gonna stop share.
Okay, well, I'll go back to the moon then. Did you want to take any questions, Rocky, from anyone?
Sure, if anybody's got any.
All right, so if you've got questions, I'll unmute everybody so that if you've got questions, everybody's unmuted. Rocky is available for questions.
I've actually got a couple more things to show.
Okay.
If you want to go ahead and.
Sure, you tell me where to go. Everybody is unmuted, so if anybody has a question while Rocky is presenting, they can shout out.
Go back to that same area you were just at.
Okay. Let's see.
Yeah, right up this way. Go other direction.
The other way.
Yeah.
All right.
That's good right there. So here's the area we were just talking about. And I think this is Mons Hadley right here. Hadley Mound, that the real is also Hadley. But this, this is the Apennine Mountains. And that's another range that's also on the Earth, I think over around Italy or Austria or someplace like that. So this is the Apennine Mountains. Okay, now let's go in this direction.
All right.
And over this way. Not doing a very good job. Yes. Okay, now move on up. Move on this way. Other direction. Okay. Down.
All right.
Okay, these three craters right here are a real neat place to look at on the moon. Let me clear out my things. But this is Ptolemaeus, Alphonsus, and Arzakel. And so Arzakel. So that is that's a kind of a signpost because you can pick out those three craters because they're all in a row and they kind of look like an upside down snowman, don't they? But Ptolemaeus is the oldest crater, and then Alphonsus is younger, and this one is younger still. And you can see how high the walls are in this one. And most craters have central peaks like this, especially the recent ones that they hadn't been beaten down or something. And Carl's not on the phone, is he?
No,
but
no,
he used to do experiments at star parties and things where you drop an object into a flower or something, and it shows you how it'll bounce back and peak up. So I wanted to show you those three, and then if you'll move on up toward the top of the moon into the lunar highlands, this down. Sorry.
No, I'm learning.
Stay on the terminator. Yeah, on up a little bit farther. Right here. I wanted to show you this hole right here is part of the crater Clavius, which is the second biggest crater on the moon, and it's the only crater you can see naked eye. And the reason you can see it naked eye is because just like right now, you can see it's like a bite out of the moon because it's on the terminator. So that's when you can see it naked eye. So that's a very old crater, but it's also the second largest on the moon. The largest is at the other end of the moon. And you can probably, you might be able to see that hole in the moon right there now, so you can go out and see a crater naked eye. So anyway, that was all I had in my list of things, so I can take questions now if anybody's got any.
Was there anything that we didn't look at that anybody wanted to slew around to? I'm happy to move the scope, or if you want to go back to one of the areas.
I think it's interesting that we can
Can we
see
look
the
at
speed.
Tycho?
Tycho's not out yet. One of the things I forgot to tell you though about Apollo 17, I don't think it's out, is that Apollo 17, which was way down at the other end of the moon, and it was the one that was in the deep valleys, it had 3 different features there. The reason they wanted to land there, they had lunar flyovers. They'd seen rock boulders that had rolled down from the mountaintops down into the valley. And so they had those boulders. So they got rocks from the top of the mountains. They got lava flow and basalt from the valley itself. And there was also a ray from Tycho that went through that area. So they were able to gather material from a Tycho ray in that area. So that was one of the neat things about that. Yeah, Tycho's a couple of days out, I think.
One of the things that I always enjoy is along the Terminator, these little peaks like we're seeing. Of course, I'm using my mouse now. I need to figure out how to do the annotation, but towards the middle of the screen to the left-hand side, there's just a small, well, maybe you can see my mouse since I'm sharing.
I see your mouse.
Oh, yeah, we see it.
Okay. So right in here, you see just this black, shadowy, there's nothing there. It's nothing but shadow, but sticking above it all is the peak of that central peak.
Yeah, I love to point that out at star parties to people. It's
Yeah.
a very slow sunrise.
Right.
On the moon.
Well, I'll go ahead and cruise the Terminator while we're here and let Rocky or anyone that has questions take us out.
You can see the dark on the illuminated side and the illuminated peaks on the dark side.
Yeah, and sometimes you'll see a peak way out in the dark, and it's where there's a mountaintop.
It gives you the sense of the 3-dimension of the elevation.
Uh-huh. Something Harry Jameson used to do was he used to look at little mounds on the moon and measure them.
Domes.
There you go.
Lunar domes.
So,
in fact, that might be one, could be, well, it sort of looks like one near where his pointer was.
Yeah.
So there's a distinct shadow line right here. I'm going to brighten this up because I'm seeing it better on my machine here than I am on what's being broadcast out. I'm going to brighten this up quite a bit, but there you go. You can start to see that.
A little more. There you go. That's an interesting feature, isn't it?
Right in here.
Looks like
it's almost like a ridge line or a.
I like that crater next to it too. That's not the straight wall, is it?
I don't know, Rocky.
Well, it certainly is straight. I mean,
it sure looks like it. I'm looking at another. Let me do something. See if that's what that is.
Is the straight wall in the midst of a crater?
Yeah,
That's the straight wall.
I think so.
Was that David Reynolds?
It was.
Yeah,
David Reynolds.
that was me. I just looked it up. It's not like I knew.
How you doing, David?
It sure looks like a straight wall to me.
Yeah, I'm looking at a picture of it online. It's got that little crater.
Yeah.
With the little bitty nodule right next to it.
Does it say what the name of the crater is? Oh, here you go. This bit is this crater, right? Yeah, I see it. The-bit.
Hey, Chris.
Yes, sir.
Drop it just a little bit.
Dimmer?
a little bit dimmer and go up. And my up is actually up on the picture. Nope, wrong way.
The other up. Okay.
The other up, yeah. Yeah, and bring the whole thing to the left just a little bit. I'm not pointing out anything I know. I just think this is interesting. Where your pointer is right now, that you see the peak in that crater, there's sort of a line, another line. It's not like what we were just seeing, the straight wall, but there seems to be a line in that crater running almost the same direction.
Yeah.
From bottom to top, going right through the peak.
Well, there's a number of those. There's a number of those right in through here.
Yeah, that's what I'm talking about.
There's also some
Like a spinner.
Right, and there's some structure here and some structure here along with that.
Same direction.
Right.
I don't know what that is. I've never read about that.
That one in the middle is bisecting two craters.
Yeah, it is. It goes through here.
Oh no, to your right.
Oh, this one?
Yeah.
Oh,
To your
yeah.
right, yeah.
Yeah.
Well, there's another one up here a little further to the right.
Here?
And more further to the right of that. Shorter one. I don't know what those are. I've never read anything about them.
No, I don't either.
I wonder if they're like that. I think it's called a graben that you showed earlier. The area that's slumped, where the crust is slumped.
Oh yeah, yeah, they might be. That I think that's the straight wall actually is not nearly as dramatic as it looks like. There's not as much slope as you think. It's not like a bluff or something like that. And what I've read about it is kind of mild. That's this area here, which actually looks like a sword, especially like it is right now.
They're finding quakes on Mars, and I may be amiss here, but I'm thinking I read that they know that they don't have tectonic, or they don't believe they're tectonic plates, but there's nevertheless quakes, and they think it's just a matter of the process of cooling and continuing to shrink from the cooling process. Create these little quakes. But now we've got another one of those gouges at the top of the screen.
Right.
Yeah. See it? See that small crater with a bright wall, then to the right of it? It's not as long as the others, but it's running the same direction.
All right. Well, I'm going to continue on up. Here's an interesting structure that Rocky might know something about. I'm going to point right in through here. This looks like a reel going in through here.
Yeah.
And down into this valley. Maybe continuing over into here. I'm gonna try to touch the focus up just a scooch. I may or may not make things better, but I will definitely in the short term make things worse.
So Chris, you're physically at the scope.
I am sitting outside in what is an absolutely wonderful night. So yeah, I'm sitting out here with a hand controller in my hand. I got a cup of decaf coffee and two machines that I'm trying to make sure that everything is running right. We've got some stuff to figure out on these presentations, but I tell you, it's nice to visit about astronomy and see everybody.
It's been pretty good. This is a Mare Vaporum right here. Oh, I ain't got my thing on now.
What are those dark spots there in the middle of that Mario.
I'm looking at a lunar map and it doesn't tell me except that it says there's a lot of wrinkle ridges, which are just where the different ways the lava froze in place.
Wrinkle ridges.
Yeah, they're just lava formations. I guess that's what that is. Let me look. There's one more thing I can look at here to see if it tells
what
me.
you circle though look like dark, some dark spots.
Yeah.
Unusual dark spots, like somebody sat on it.
Yeah, it's not telling me anything about them. There's some little craters in there, but they're not telling me anything about those ridges.
Chris, let me ask you something about your setup here now. Are
Sure.
we looking at this at the native magnification, if that's the proper term for it?
We are. So what we are actually looking at is I have a small monochrome planetary CMOS camera with a small chip, and it's at the prime focus of a standard Schmidt-Cassegrain 8-inch scope, no Barlow, no nothing. So we're at about 2,032 millimeters of focal length, and I'd have to do the math to figure out what the angular resolution per pixel is, but it to me it's kind of a sweet spot for doing something like this, because much more magnification and you wouldn't be able to tell where you were, and much less and you wouldn't be able to see anything.
Yeah, and you're not able to change the magnification.
Well, I can physically, go into the program like right here and tell it to do, a 200% zoom. So I can do that, but you see what happens is you really start seeing the seeing.
Yeah.
So there are moments
we're originally seeing it at 100%.
We're seeing it. So 100% is here.
Yeah.
And I had it to where we could see the entire image at once, which is here. So we're really close to 100%.
So do 150. I'm just curious.
Sure.
All right.
So if we did that and we went back to say that straight wall feature.
Yeah, you'll have to brighten it a little bit.
Mess with the exposure a little bit here.
I did some Googling about the stripes that we were seeing earlier along the face of the moon that were all kind of going in the same direction.
Yeah, they know.
So I just Googled like stripes on the moon, and most of them kept coming up to the stripes on Saturn's icy moon, Enceladus, I believe. But I found this one article from NASA about the Tycho crater, and it was talking about how a lot of the striations that you see on the moon like that now, especially in the southern hemisphere, which I think is where we're looking, are created by that impact, which would make sense that they're all kind of in a line because, as you go around, they all kind of point in the same direction. But the reason they're so prominent now is because of how recent that impact was in comparison to a lot of the others. So I guess that's a possibility.
So this is just stuff blown out of the Tycho impact?
Potentially.
Created a...
Well, I think you're talking about these grooves, aren't you?
Yeah, that's what he's talking about.
Yeah, well, this is a ray. Let me draw it. This looks like a ray right here, but you're talking about these grooves right here.
Oh,
like
yeah, good point.
Yeah.
That is a good point.
Yeah, those Tychos, yeah, if you had never seen the full moon look at the full moon, especially with a filter, sometime, and you can really see Tycho's rays at full moon.
Mm-hmm.
Chris, block the magnification way down, all the way down. Maybe we can get a sense of those rays. Can we see Tycho? Is it illuminated?
No, Tycho's not
Still
good
in
to
the
look
dark?
at right now. It's in the dark side. But if you want to, yeah, I showed you a ray on Messier A and Messier B. You remember
Mhm.
that
Oh yeah,
over
yeah.
on
I know what the
Fecunda
rays
Titan?
look like.
Yeah, and
Yeah, there's some rays right
yeah,
there.
right here. But there's also rays out of some of these other bright craters also.
Yeah, I don't know what those
Here's
striations
some
are.
rays. There's a neat crater. I wonder what that is.
Yeah, that's a good point. I guess maybe it just has something to do with before everything was so solid on the moon, potentially.
I tell you what they look like to me. They look like where um, an asteroid or something crashed into the moon, and then it blew out rocks, and those rock and they would hit like ridges and stuff and make grooves in them. But I don't know
Yeah,
if that's what it is.
or maybe just like an
Well, they
asteroid that came in at more of an angle.
Right.
Yeah, but they all parallel one another. That we were seeing. It's one right
Mhm.
after another in parallel.
Yeah,
It's interesting. We need to look into it. Somebody's got a theory about it because it's
I'm sure they do.
right. But they're pretty long too. Some of them are pretty long. It's hard to imagine any kind of grooving process doing that. It's got to be some kind of crust collapse or something.
Were they grooves or are they raised areas? Because looking at the image, it looks like the sun might have been illuminating the right-hand side, which would make them.
So were we here, or were we up? We were up at where we were seeing the straight wall.
Yeah, over around Ptolemais is where Bruce first started, just south of the Straight Wall.
Okay,
That's up in the middle.
that's a pretty mountain range.
It really is. It really looks rugged, doesn't it?
Yeah, let me brighten that up a little bit. I'll get us back to where we were looking at those rays, but
Yeah, that's the Apennine Mountains.
Oh yeah, that's beautiful.
we'll look at those at
Oh, that's really
100%.
good.
You know, the moon has a zone where the lighting just really brings it to life, and then as you get over to the full lit area where it's more face on, things get flat and a lot less interesting.
Well, it
Yeah.
really looks rugged, doesn't it?
Yeah.
Looks like the mountains outside of Tucson.
Now there's an interesting, I guess, is it a reel or a
Yeah, there's another
something
reel.
going
Yeah.
right through there, and I'll zoom in on that just to give it a look. Gets a little bouncy, but
Yeah. Yeah, it's a slight improvement. It's
That's
soft.
that's Rama Bradley. And that's just south of the railroad I was talking about a minute ago. In this area right here is where Rama Hadley is. This
okay.
is Rama Bradley. And
Now, how do you know that, Rocky?
I'm looking at a virtual moon on another computer.
All right.
Well,
I figured you cheating somehow.
a lot of this stuff I know, but I don't know little things like that.
Well, every once in a while that really snaps in and is very nice.
It
Of course,
is.
I have the advantage of seeing it like right straight on the computer that's being fed to the presentation, but it's able to freeze the seeing there, and you actually start to see structure on either
So
side of those.
let's go back and see those striations again real quick.
Okay.
I think they're further down the picture.
Okay, there you go. You're, there's the straight wall, but they were, what Bruce was talking about was up in this area.
There's right there in the, oh,
Right
yeah, there's a bunch
there,
of them.
there.
Yeah.
Now, can you inflate that just a little bit?
Sure.
Because David thinks, and I agree with him, on the one on the left, definitely looks like a raised area in places. Whereas on the one on the right looks like a gouge.
Yeah, they just like completely ignore the rest of the topography of the moon,
Right.
which is
On
interesting.
the craters, the lit side is on the left and the dark side's on the right, but it'd be reversed if it were a raised area. I'm still looking for them and can't see them now. Can you point at them?
Yeah, sure. So we've got here, here, here. I think those are the three primary that I'm seeing.
Yeah, and you see the first one you pointed out down at the left. That's like David says, it's dark on the right and lit on the left.
So that's an indentation. But the
And
other one up there on the right, it looks like it's raised to me.
yeah, some of them look raised and some of them look, to me, they look slightly recessed. But then maybe that first one I'm seeing inverse. Yeah, I think they're all recessed. I don't know. You might need to see that, directly with a telescope to really tell. But they're parallel striations and they're all over that place. It's interesting.
The teleconferencing service is probably doing some sharpening of the images, and that may be causing things to be a little weird.
The craters here actually look like they're elevated.
Yeah, sometimes they do, and sometimes they they look the other way.
Yeah, your eye plays a trick on you.
Hey, move up just a little bit, Chris.
Sure.
I want to see this crater right here.
Up or down?
You're going right. Right. Stop.
Okay.
I'm just looking at a. Now let the picture come in, because right now they look raised to me. Everything
Now
does.
your pointer looks like it's pointing at a graben.
Okay.
Here. I'll move my
No.
pointer.
Oh, maybe that's not your pointer. Over here, you see this little crater in the upper left part that's really bright on one edge. To the immediate
Here?
right of that. To the immediate
Here?
right of that is left over here, far left corner.
Oh,
Here?
sorry.
Yeah, see that? Now look to the right of it. Just a line going again, I guess north and south. Just to the right of it. Looks like
Oh yeah.
There's an interesting line of almost a ripple of craters going right through here. I don't know if you can see that. Let me brighten it up a little bit.
Yeah, isn't that neat?
See,
Each one getting smaller than the one before.
it's almost like rock skipping across the lake.
Uh-huh.
Huh.
All right. Well, I think we could do this all night long. Did anybody have any questions or anything they wanted to see? We've been going about an hour now, and
I
don't know.
appreciate you doing it, Chris.
Yeah, it's been
Well,
fun.
Thank you, Rocky.
Yeah.
Thank you, Chris.
Rocky did the work.
Thanks again from me.
All right.
Yeah.
Thanks, Rocky. Everybody have a good night. Stay safe.
Take care, guys.
All right. Good night, all.